Look, everybody, fan mail. Let's see what it says. Let's see. Dear Mr. Hawk, I am really enjoying your videos. Oh, thank you. But I'm starting to wonder if any of this is ever going to help me. I want to own my own business someday, and I can't see how quadratic equations are going to make me any money. Sincerely, Bummed Out in Brooklyn. P.S. Do you have a dog? Oh, I do have a dog. And I think you're really going to like today's episode. Because in today's episode, you're going to learn how to maximize your profit. All right, so where have we been? Well, here's what we've already learned how to do. One, we've learned how to graph quadratic equations like this one here. You can tell it's a quadratic equation because the highest term is the x squared term. There's no x cubed or x to the fourth term. We've learned how to factor to solve these quadratic equations, which will allow us to find the zeros. We can explain key features of parabolas. Here you see a parabola that's concave down. We can find the domain, which is all the possible x values. Today it's going to look a little bit different because it's not just everything that shows up on the graph. We're also going to have to pay attention to the context of the problem. We've learned about the range, which is all the possible y values that we can have, and also we'll have to pay attention to the context to see what range actually matters here. In addition to that, we've also determined what the vertex means and where it is. We're going to use that today to maximize our profits. And we've found the zeros. That's the x values that make this function equal to 0. Today, we're going to put it all together in the context of trying to maximize profits and beyond, which means we're going to need to pay attention to the vertex. Where is it, and what does that point mean in the context of the problem? Tomorrow and beyond, we're actually going to be solving quadratic equations using other methods. So we're going to continue to use factoring, but we'll also be using some square roots. We're going to be completing the square, we'll be learning vertex form, and then you guys, I cannot wait to share with you the quadratic formula. It'll literally allow you to solve any quadratic equation. It's going to save your life on the SAT and when you get to high school physics. All right, let's get into it. Maximizing profits. So we're going to see a lot of problems like this today. I'm going to ask you to read it, and I'm going to read it out loud as well. You were throwing a giant party to raise funds for your favorite charity. Oh, that's nice of you. You found a venue that can hold up to 1,200 people. You know that if you charge $5 per ticket, you will be able to fill the venue. You are also estimating that for every 50 cents you increase the price of the tickets, 100 fewer people will attend. So for example, if you charge $5.50, only 1,100 people will buy tickets. That's 100 less because you increase the price by 50 cents. Your earnings then will be P of x equals 1,200 minus 100x times 5 plus 0.5x. So the first term, 1,200 minus 100x, is the number of people who are going to buy tickets. And the second term, 5 plus 0.5x, is your price that you're charging per ticket. $5 plus 50 cents times something. You have two questions you want to answer. A, for what ticket price will you earn a profit that you can donate? Meaning, for what prices are you going to earn a profit at all, even if it's like 50-cent profit total? B is, what ticket prices will maximize the profit? So how are you going to make the most money? It's an interesting problem. So to get started with this, I want to make sure that I understand the situation. I think that I do, but just in case, I'm going to ask you to pause, and in the chat or in the Desmos activity, I want you to answer the question about what this question is really asking. Welcome back. So here's what the question is really asking. It's asking two things. For part A, it's asking when is the y value more than 0? Meaning you want to know when you can earn a profit. That means that the P of x is going to be more than 0. It's going to be a positive value. B is asking you essentially for the location of the vertex. For what ticket prices will you be able to maximize the profit? Meaning you're going to get the most. So in the graph, that's going to be the vertex. All right, so we have to find the x values for which y is greater than 0, or P of x is greater than 0. And then we have to find the location of the vertex. We know how to do both of those things. I'm going to pause here and ask you to do both of those things on your own in Desmos or in your Google Doc, and then you're going to come back and see how we did. But I'm going to show you what I did, even though maybe it didn't get me anywhere, because I think there's an important lesson here. So you'll see that the first thing that I did is I took the original expression and then I expanded it, right? I multiplied all the terms in order to get what you see here. And then I rewrote it, so I had the x squared term first. Then I factored out a negative 50, and then I decided to factor that further so I could find the zeros. When I did that, look at what I got. It's exactly what I started with, so I did all that for nothing. You know, guys, sometimes when you're solving these equations, or when you're doing math in general, you're going to go down one solution pathway and realize that it didn't get you anywhere. But that's important, because from that we can learn that what we started with actually had all the information that we needed to begin with. I didn't need to do all that. You might not have done all that. Good for you. Okay, so now that we have this factored, which turns out we had it factored all along, we can find the values of x for which this is equal to 0. We can find the zeros. So for the first term, 1,200 minus 100x, what value of x would make that 0? Well, if x is 12, then we have 1,200 minus 1,200, or 1,200 minus 1,200. Yeah, that would be 0. So x is 12. So when x is 12, p of x is 0. What about the second term? Pause for a second, and in Desmos or in the chat, I want you to find the value of x that makes 5 plus 0.5x equal to 0. And I'll give you a hint. You can just do 5 plus 0.5x equals 0 and then solve for x. Go ahead and enter that in the chat or in Desmos now. All right, so hopefully you found that the value of x that made that 0 is negative 10. When x is negative 10, that second term is 0. So we have p of x equal to 0 when x is negative 10 and when x is 12. So now we can graph this, and that will tell us the values for which p of x is greater than 0, right? It's when it crosses the axis all the way until it crosses the axis again and goes back into the negatives. So that'll tell us the domain over which we're going to make a profit, meaning the x values for which p of x is positive. Anywhere from negative 10 all the way up to 12, not including negative 10 because then we make $0, and not including 12 because then we make $0 again, but anywhere between those, that's going to give us a profit. We can also use that to find where the vertex is. If we know that the vertex is halfway between negative 10 and 12, we do negative 10 plus 12 divided by 2, and that gives us 1. So when x is equal to 1, that's where we're going to find the maximum profit. So what would be the price of the ticket when x is equal to 1? I want you to go back to the original expression and find the price of the ticket if x is equal to 1. You're going to have to interpret what each of those terms mean again. That's right. Hopefully you found that when x is 1, it's $5.50. So that's how we make the most profit. We charge $5.50. And we could find how much profit we would make, but the question doesn't ask us to, and I don't really feel like it. All right, so that problem maybe seemed a little intimidating. There was a lot going on there. So I just wanted to recap, because from now, you're going to start doing this on your own and with your teacher. And I want to just be clear about what we did together that allowed us to find the maximum profit. So the first thing we needed to do was we needed to interpret the problem. We needed to know that the vertex meant the maximum point, which meant the most profit. So we had to know that we were looking for the vertex, which was the case because we knew p of x was the profit, and if we're trying to find the most profit, that means the highest value, which is the vertex of the parabola if it's concave down. Then we needed to interpret the domain restrictions. When it said make a profit, that meant that p of x needed to be greater than 0. That told us that we needed to find the zeros, right? Find where it was 0, and know that anywhere in between there, the value of p of x was going to be greater than 0. It was going to be positive. Finally, this was the hardest part by far, is we needed to interpret the values in the problem. So once we found that the vertex was at x equals 1, we still needed to figure out what the price of the tickets was. That x equals 1 doesn't tell us the price. So we had to know that the first term was the number of tickets, and the second term was the price of each ticket, and then we had to substitute the value of x to figure out 1, the number of tickets sold, and then 2, what we really wanted to know, the price of the tickets that would maximize the profits. In this case, 5 plus 0.5 times 1, or $5.50. Just a quick note, anytime you see 0.5 in the context of a money problem, mentally you should equate that with 0.50 or 50 cents. Half a dollar, 50 cents. Same thing. All right, guys, so you're about to go and do this with your own problems. Hope you have a great time. I look forward to seeing you again tomorrow. Keep mathing on. Bye.